video we'll be talking about a very interesting topic called the mechanical sympathy. This is a term that was introduced by the brilliant Martin Thompson. What it means in a nutshell is that your knowledge of the inner working of the underlying system allows you to write code that runs efficiently on that system. So let's see how that works. So this diagram depicts the relationship between the CPU and the different levels of memory. As you can see, the further we go from the CPU, the larger the memory gets. But at the same time, the access gets slower and slower. So with this architecture in mind, two things come to mind. The first one is the data size. So size matters in this case. And the second thing is the data access pattern. So the first one. So if you are working with a piece of data that's large enough to fit in L1, or it's bigger than L1, then you need to store it in L2 or L3 or main memory. And if it's big or huge to fit in the main memory, then we need to dedicate a part of the disk to use as an extension of the main memory, which will make your application really, really slow. So if you want to write efficient code, always keep that in mind and design your app in a way to always deal or process small chunks of data that are like large enough to fit in L1 or L2, but never force the CPU to reach out all the way to main memory. So if you do that, you're gonna reduce the context switches for the CPU, and CPU will be able to process your data really fast. So the second thing is the data access pattern. What that means is whenever you are dealing or working with a data structure, you have sequential access or random access. So always try to go with the sequential access. Why? Because the CPU, when it's working with a piece of data and it's about to finish with the data and access more, there is a process called the prefetcher. And it's basically what it does, it tries to predict the next piece of data and try to go and load it before the CPU is done. And it does it loads it into the cache line. And like when you are accessing your data structure sequentially, it's really easy for the CPU to guess this, the next set of data to load. Usually the cache line is about 64, sometimes 128, or even 256. So if you do it sequentially, it will be really easy for the CPU to guess the next cache line to load. But if your access is random, then it's almost impossible for the CPU to guess that, and you will force the CPU to perform context switches, to look for the next data in the low level of caches, and then just to load them to work with them. So yeah, that's about it. And if you have any insights or questions, feel free to leave them in the comment. Thank you and have a good day.